Hi students, let's look at this question which was taken from the Specimen paper, 2017 paper on question 16. This is H2 mathematics. This question is on vectors. So let's look at the first one. Now the non-zero vectors A, B, C are such that A cross B equals to C cross A, given that B is not parallel to C, or B is not equal to negative C. Find the relationship between A, B, and C. Okay, great. So let's see how we can do this. The first thing is I will suggest we just going to try and take out the common vectors here. So here, what we have is essentially bring this over to the other side. This A cross B minus C cross A, and this will give us a zero vector here. Okay, so when this is a zero vector, okay, this is not zero. This has to be a zero vector because it is a vector. This over here just means that it's 0, 0, 0. Okay, all these vectors undergo this operation here. They will just yield a 0, 0, 0. Now, then the other thing is we need to, if we can, we factorize out one of the vectors out. Okay, what we can do here is, because this A is in the first position here, so this A have to move to the first position as well. What you can do is actually just remember, when you flip, so minus, this will be negative A cross C. Okay, that will be okay. Now once done, okay, of course you can skip step here, but I'm just going to slowly do it so that this is alright. Okay, once they are in the same position here, so meaning if they are in the first one and the first position here, if they are in the same position, then only you can sort of like, you can factorize the A out, right? So you factorize this A out, B cross, what is left behind is B and C. Okay, so this is B plus C here, and this is zero vector. Great. All right, so once done, we want to find a linear relationship between A, B, and C. This is it. If you take, this is a vector, this is a vector here, and this is also another vector. So these two vectors, when you cross them, you get a zero vector. Okay, just take note. So if say M cross N is 0, what we can deduce is M and N are parallel. Okay, because of the cross product. When theta is 0, okay, M cross N unit vector will just be mod N sine 0, which is actually 0. Okay, this is a zero vector here. So to get a zero vector will mean that you have to be parallel to each other. Okay, just take note. So M and N up, they are parallel. So from here, what we can deduce is actually A is parallel to B plus C. As long as cross product, okay, you will get a parallel vector. So from here, what we can deduce is A equals to K, or you can just write down, because we need B, right? So B, what do they need? They need a linear relationship. Okay, so A is equals to K B plus C, where K is a constant. Okay, yeah, that's about it. This is a linear relationship. You can just write it as such, or you can just put the K on the other side, then it looks nicer, but this is fine. Okay, let's look at the subsequent part. So the variable V satisfies this equation here. So you take V cross with this, you get 2J. Find a set of vectors of V and describe this set geometrically. Let's see if I can do this proficiently. I think this is pretty interesting. So for part 2, I'm going to just write down what was given to me. So V cross with I, which is 1, 0, minus 3, equals to J, 2J, so 0, I, J, K. Okay, great. So this is what I'll get. Okay, now what do I recommend you doing is at least just try and understand what the question is asking, in the sense that draw it out. So let's say V cross with 1, 0, minus 3. You know that when you cross it, you get a normal vector to both, right? So this case here, what we get here is this, let's say this is V, and this is 1, 0, negative 3, and we cross them, you will get a normal pointing upwards. Okay, I'm not sure what is this normal here, but it can be just 0, 0 to 0, just a sketch, just for you to help you understand what's going on. So I'm going to take a vector, and now this vector here doesn't have to be perpendicular, so this cross with this give us 202. Okay, that's so now we are told to try and understand what is this V here geometrically. Now we know that from the look of it, this V here is like a vector. If V is a direction vector, this direction vector cross with this will give us this normal here. So if you can find this equation here is like a line, then you'll be able to get the define this geometrically, right? So the first thing is I'm just going to let V be xyz first. I'm not sure what it is, so let V equals to xyz. These are the coordinates, right? So I'm just going to put it in here, so it's x, y, z, and try and make sense of what will x, y, z constitute to get 202. So this case here, just use a cross product. All right, cross product here. Y, this is minus 3y minus 0. Then cover this is minus 3x minus z minus. And then we have got cover this minus 3y, minus y, 0 minus y. Okay, so this is 202. And what we'll get is minus 3y, 3x plus z equals to minus y is 020. Okay, now you gather that actually it really doesn't matter because y coordinate is always 0. So minus 3y is 0. Okay, so 3x plus z is equals to 2. And minus y is just 0. Okay, so now v could be reduced to, we know this would reduce v to this coordinate here, which is x. We have x, 0, z, right? So z is actually 2 minus 3x. Am I right? Maybe I just put this as x, y, z. Okay, from here we can tell that, okay, if this is x, it doesn't, because this y is 0 and z would be 2 minus 3x. Okay, it will follow this equation here. Just take note, this equation it will follow. So x could be any variable. Actually, it could be any variable. It really doesn't matter. But what we can write down is now if v were to satisfy this equation here, we're going to split this up into say 0, 0, 2 plus x 0 and minus 3x. All right. Am I right with this? Minus 3y. Yeah. Okay. So this is obviously arbitrary. So we can just let when x is equal to lambda, it really doesn't matter. So we have v is equal to 0, 0, 2 plus lambda 1, 0 minus 3. Okay, real value. X is arbitrary. Okay, is really arbitrary. So this case here, we get a line equation, a very neat line equation. So in other words, if this equation here follows this line equation, we take this line equation cross with this, we'll get this normal here. Okay, the vector there. So let me just rearrange this part here. Okay, maybe I shouldn't rearrange. So this case here, what I can write down is v satisfy the line equation. So let me just write it down. So v the set of v, the set of vectors, what did they ask here? Set of vectors v, the set is vectors v, set of vectors v contains are points on the line which passes through 0, 0, 2 and parallel to I to 1, 0, 1, 0, negative 3. Okay. The sort of are points. Okay. Parallel to I minus 3j. Okay. So that's how we define the set of value of v. Yep. I minus 3k. So that's how I do this question proficiently. If you have any questions at all, please let us know, and I'll see you in the next question.